please listen carefully. Then you need not to go through any books or any notes. If you listen carefully what I am talking about, you can interface anything. Just you have to follow the basics. Suppose any question came, now you want to interface the keyboard, yes. Whether you can interface the LCD, yes. Whether you have to interface the LED, all these things can be interfaced with your 8051 microcontroller. So first of all, we will be discussing with 8051. Then we will be discussing with 8086. First of all, I will today in today's class, we will be discussing how to interface 8051 with LEDs or LCDs and etc. So I will be telling you the concept, how to interface, how to proceed to interface. What are those things required to do these things? Instead of telling that this is the program for interfacing this one, this is the program for interfacing this one, just please, sir, tell me the concept. The concept part, please tell me so that accordingly we can plan or we can program any device which we want to connect. Okay, is it okay? So just whatever I'm saying, don't skip any single line. Then in the otherwise you will face a problem. So now first of all, sir, in this today's class, what we want to do? So we want to interface. Suppose we can interface so many things. So in this class, I'm going to tell you how to interface the LCD with your 8051 microcontroller. So this is the program we are talking about. In this class, we will be discussing this thing. We want to interface the LCD with your 8051 microcontroller. So that means we will be learning how to interface the LCD with your 8051 microcontroller. Okay, sir. So not only the LCD, sir, in order to interface anything with the microcontroller, in order to interface anything with the microcontroller, we must have some basic of the device which we want to connect with the microcontroller. Okay, sir. That means these basics are for every question. Whether you want to connect LED, whether you want to connect LCD, whether you want to connect switches, whether you want to connect the keyboard, anything you want to connect or interface with the 8051, you must be aware of the basics of those device or the device which you need to connect. Is this clear? First point is clear, yes or no? Just tell me. This step or the first point is clear? Good. If this is clear, sir, that what is basically the basics. So in this class, we will be discussing the some of the basics of LCD. What is LCD and how LCD looks like? What are the features of LCD? Then only we can connect. So in these features or in these basics, first of all, we will understand what is LCD means. LCD is basically a liquid crystal. Full form is liquid crystal display. Okay, so okay, sir. Now this LCD comes in so many configuration. For example, 16 cross 1 LCD. Okay, sir. Second, 16 cross 2 LCD. Third one is the 20 cross 4 LCD. That means these LCD not only comes in one configuration, but it comes with a several configuration. Out of those configuration, we will be discussing 16 cross 1, 16 cross 2, and 20 cross 4. What is the exact meaning of this, sir? The meaning of this is that here 1 represent the number of rows. How many rows? Sir, 1 rows. How many rows, sir? 2 rows. How many rows, sir? 4 rows. This represent rows. This first represent rows. That means how many rows? Only 1 row. How many rows, sir? 2 rows. How many rows in this? There are basically 4 rows. Okay. So that means, first of all, we will understand these basics. What is exactly the meaning of 16 cross 1? Now, what is the meaning of 16, sir? 16 is the number of character. So in this row, how many character you can type? We can type characters from 16 character. That means from 0 to 15. That means total 15 character we can type. Okay. In this, sir, this also one row we can type 15 character, and the second row also we can type 15 character. Similarly, sir, how many rows? 4 rows. And how many character you can type? So you can type 20 characters. That means this 20 represents the characters and this 4 represent the number of rows. Is I am clear to all of you? The second point is over. Yes, point sir. Number. Okay. The second point is clear. Okay, sir. When the second point is clear, now moving on to the third and very important point. The third point is that the LCD may be alphanumeric. The LCD which you see is alphanumeric. You must know alphanumeric means we can type number as well as alphabet, both. Not only the alphanumeric LCDs coming in the market, there are so many graphical LCDs also coming, in which graph is basically made. But now in this class only, we will be discussing this mostly used LCD pattern, or the LCD which is basically alphanumeric. Alphanumeric means in this you can display the alphabets as well as you can display the numbers from 0 to 9. Is the third point clear to all of you? Yes or no? Please.
Yes, sir, clear.
Good. Now coming to the most important point. This is very, very important, because if you don't know, you will not able to program the LCD by using microcontroller. This point is tell you now. Sir, we can use 16 cross 1 also. We can use 20 cross V. All the LCD will work similar, but look at this. This is an LCD and we will be discussing this LCD which is having 16 cross 2. So we will be discussing 16 cross 2 LCD. This is row number 1. So this will count from 0 to 15. That means 16 character. And then this will again count to 16 character. There are two lines. This is 16 cross 2 LCD we are talking about. So now this LED, we have several pins. Okay. The first of all, this LCD, we can type or send data from the data bus, that means D0 to D7. So this is the data bus of 8-bit long. In this LCD, you can send data which you want to display on the LCD by using a bus, that is data bus. And the data bus is coming, the data is coming from the symbol, that is D0 to D7. So that is in your LCD, there are 8 pins are provided to you. All these 8 pin will be used to send send the data from the microcontroller to the LCD display. So now this point is clear, sir. Yes or no? That means this pin comes with an 8 pin. All those 8 pin from D0 to D7 will be used to receive the data or the command which you want to display on the screen. Yes or no? Is it clear? Is it clear?
Yes, sir.
Now, there is one another pin. The pin name is, there is one another pin in the LCD. This is called the resistor select. This is called resistor select, and this is given by the short form RS. There is another pin in the LCD only. This is used for a resistor select. First of all, inside this LCD, there are two resistors. One resistor is called the command resistor. Two register, that is command register, and another one is called the data register. Inside your LCD, there are two registers are present. In one register, the command will be stored. In the second register, the data is stored. So the data register basically takes the data, and the command register basically receive the command what it need to perform this information will be stored inside this register, and the data which you want to display will be stored inside this register. So that means suppose if you want to display something, we need a command. Those command will come from the microcontroller. So the command is coming from the microcontroller. The information will be saved inside the command register, and the data will also again be coming from the microcontroller, and this will be again stored inside the display only. Now, how to select this, sir? So this can be selected by this pin, RS pin. So now when RS is equal to RS can be selected 0 or 1, depending upon that you are selecting either command register or you are selecting either data register. How to choose this? I will tell you further. For the time being, this much is clear or not? Yes or no? Yes or no?
Yes, sir.
Good. Now there is another pin provided to this. This is called the read and write pin. This is very simple, sir. That means if the read pin is 1, that means you want to read something from the display. If the write pin is 0, that means you want to write. So accordingly, if you want to read something from the display inside the microcontroller, or you want to write something on the display, this pin have to be set or reset upon depending upon the situation, whether you want to read or write. Okay. Now the third and the most important pin is that this pin is called the enable pin. The enable pin means you are enabling your LCD for taking the data for certain pines. Only remember that whenever you want to read or whether you want to write, you have to in on this enable pin for certain period of time, and then you have to is of this enable pin. That means ideally speaking, the working of this pin is that whenever you want to send a command, whenever you want to send a data, in both the case you have to first enable your this pin, and then you have to disable your pin. What is the meaning of this, sir? Meaning is that you have to set this pin, that means set B, if you remember, set bit, and then you have to clear this bit, clear this bit. That means only thing is that whatever pin this is connected, you need to first on this pin, and then you have to off this pin. That's it. That means this is the pins we are basically looking forward to. That means we have to send data through this pin. We have to select whether you are sending command or whether you are sending a data will be decided by this pin. You are reading or writing. This is decided by this pin, and then this is basically enabling. If you are writing or reading, it does not matter. Only thing is that we have to make this enable pin 1, and then we have to clear this pin. That's it. Okay, so this is an enable pin. After that, there is one more pin I have already pointed out, sir. Every device needs a power supply. To give the power supply, this power supply is given from this. This is the resistor you're talking about. This is V, this is ground, and this is basically a VCC. And now there was another potentiometer use. This is the potentiometer. One is given to the first row, second one is given to the second row, and this is basically your VEE, and this is basically your VSS. The ground is connected to VSS. That means indirectly speaking, you are saying, sir, each display device or LCD or LED require a power supply. This power supply is given with a plus VCC voltage and some ground voltage. And in this, these voltages are given to row 1 and row 2. And this is done. This voltage basically control the brightness. What it contain? It will contain the brightness of the LCD on which you want to show something. So by moving this potentiometer up and down, that means by changing the resistance, you can control the brightness with which you are able to see display the anything on the board. So this pin is basically used to control the display. This pin is usually given to give the supply, and this is basically given to supply the VCC or VSS. Is it clear to all of you? Yes or no? This is the only basics required to do the programming of your microcontroller or interface. This much information you must know something about your LCD. That means in LCDs that there are 8 pins which is used to send the data or the command. And other than that, we have an RS pin. Other than we have a read write pin, and then we have an enable pin. We have a VSS pin. We have a VSS pin, VCC pin, and VEE pin is basically used to control the brightness. That's it. Is it clear to all of you?
Yes,
Yes,
sir.
sir.
Clear, sir.
Yes, sir.
Okay.
Clear.
Now I'm just summarizing this above point in a simple way. That means, sir, now please summarize those things, sir, that we will be focusing on. That means these are the important pin. That means D0 to D7. Our concentration will be on that. Yes. And then we have to focus on the RS pin. Yes. Then we have to focus on the read and write pin. Yes. Then we have to focus on the enable pin. Yes. Then we have to focus on the VCC, that is plus 5 volt. Yes. Then we have to focus on the VEE pin that will control the brightness of the, this will control the brightness of the LCD. Now then we have a VSS pin. This is basically nothing but ground. So indirectly speaking, how many pins? 1, 2, 3, 4, 5, 6, 7 pin we have to focus on. This is the requirement to do programming of your microcontroller and LCD interfacing. Is this clear to all of you? Yes or no? Please let me know.
Clear, sir.
Okay, now we will be discussing this pin as single pin. Okay, so first of all, we know this is used to send the data. This is used to send data or command. We will be sending data or command with this pins, 8 pin. Now, this pin is very important. This RS pin may be 0 or this pin may be 1. Okay. When this pin you will select as a 0, this means you are selecting select command register. Select command register. So whatever is going from the microcontroller will be going inside the command register. When this RS is equal to 1, that means you are selecting the data register. That means you are selecting the data register. Okay, sir. Now coming to the this point, sir, this point coming to this read and write operation. When this is 0, that means you want to write some data, write data to LCD. You want to write some data to LCD. When this is equal to 1, that means you want to read from the LCD. This is as simple as we have already seen that this is not a big deal. Now coming to the important point, this is an EN. This is an enable pin. EN for enable. So this enable you have to make always 1 and then you have to make it 0. That's it. No need to do anything. That means you have to first enable this pin and then you have to off this pin. That's all. Okay, sir. Now, so that means these are the, and these pins are basically given plus 5 volt you have to give to the LCD. You have to give the ground as well as you have one pin was given a PVP pin. You can when you will change this pin, then the brightness of your LCD will change accordingly. So right now we will be not focusing in this one. This is not this is trivial in this example, but yes, it will be helpful when you will do physical hardware, physical simulation, or physically when you draw some project. Now these things are over. Yes or no? Hope everything is clear. Concept wise okay. Now this concept part of LCD is done. Concept part of LCD has been done. What are those pin in LCD? We must have known this. Is it clear? Can I proceed?
Yes, sir. Clear.
Now
Yes, sir.
coming to the very beautiful, this picture will basically clear your doubt. So this is our microcontroller. This is our microcontroller and this is our sweet LCD. So this is our LCD. Okay. So this is our LCD And this is our cute 808, sorry, 805151 microcontroller. Okay, no problem, sir. So first of all, look the diagram carefully. Sir, we have how many ports? Port 0. Sir, we have port 0 inside this microcontroller. We have port 1. We have port 2. And we have port 3. So there are 4 ports available. Okay. Each port have 8 bit register. Okay. So out of this port, you remember, if you remember, the port 2 is basically used to connect with an LCD, if you remember. So that means the data will be going from the port 2. Okay. So that means port 2, that means from data will be D0 to D7. That means from port 2.1 to, sorry, point 220 to port 2.7. This port is basically used to send 8-bit data to your LCD. Is it clear to all of you? D0 to D7. Done. That means the 8 pins are connected to which port? Port number 2. Is it okay?
Yes, sir.
Okay, so now this is done. So if this part is done, so now we will be free. That means now port 2 is connected because 8-bit data you want to send, you will need to send those data with the using the port 2, because in the theory class, we have studied that port number 2 is basically connected with the LED, or switch is basically connected to port 2. If all the port 2 is basically used, yes, you can use it. Only you can set 8-bit data at a time. And you are using an 8-bit data to send the to the data. Not a problem. Now, this is very important. Please look at this very carefully. So I'm just changing this P1 location for the simplicity only. You can write anywhere. So this is P3 I'm writing here, or I am deliberately I'm writing this P1 here. So we want to write P1 here. So that means this is P1, sir. Port number 1. I'm just writing for the sake of simplicity. That's it. That's it. Okay, sir. So this is our P1. In this P1 port, there are total 8 ports. So in this port, we are interested in using the port number 1. That means bit number 1. In this number, port number 1 of 1. In this port number 1, bit number 2. That means we will be seeing, that means now, sir, if we look at the previous slide, this part is done, sir. If you look at this, sir, D0 part has been done, sir. Now, how many pin we need? We need RS pin, RW pin, and enable pin. Okay, that means these 3 pin we require to connect. Okay, so what we are doing, sir, we are using 3 pin from the port number 1. That means port bit 0, 1, and 2. We will be using for our purpose. The port number 1 we will be using for this bit number 0, we will be using for the register select pin. This port number 1 and we will be using for our read and write operation. And this port number 1, bit number 2, we will be using for our enable. We can choose anything. You can choose this RS, this port number 1, bit number 2 as a RS. This depend upon you. You can choose anything. But now we are choosing the port number 1 for RS, that is port number 1, bit 0 for RS, port number 1, bit number 1 for read and write operation, and for bit number 1, bit number 2, we are using for enable. Now, what are those things left in this, sir? We are basically left with port number 1 to 4 to port number 1 to 7. These pins are basically left. We will be connecting all these pins with the ground item. We will be connecting all these rest of the bits of the port number pin with the ground. Now we will be using these 3 pin only. Why? Because we require only RS, read and write, and enable. That's it. So that is thing we are basically requiring. So now this part has been worked, sir. Now what is left, sir? The left is VCC, VSS, and VE is left. That means 3 pins are left. And we know these supplies are not taken from the microcontroller. They are given from the external circuit. So no problem, sir. We will be giving, this is basically a 5 volt. That means 5 volt supply. And this will be given to your circuit. Now this is basically your ground. This is basically, see, this is basically a ground, and this is basically plus volt, and this is given. This is given, the supply is given. That means this is your VEE now. So as soon as you will move this up or down, the VVV will change, VVV voltage will be changed. And as soon as this voltage, maximum voltage of VV will be 5 volt and the minimum voltage will be 0 because you are connecting with through the potentiometer. So that means you are connecting with the VVV and then we are giving one voltage pin to ground. So either you can connect 5 also. Sir, if you don't want to change the brightness now, so just connect at this pin 5 volt, no problem. So it will also work. But for the simplicity, if you want to do this, just connect this voltage VV within potentiometer of voltage V. So maximum voltage will be 5 and then we can change according to the potentiometer or resistance movement. For simplicity, what you are saying, sir? For simplicity, I am saying that no, sir. I don't want to potentiometer. I don't want to control the brightness. I just want to display something on the LCD. So do one thing. This pin is basically your VCC pin and this is your 5 volt. That's it. And this is your ground pin. This is connected from the externally and this is also connected from some battery or any source. That's it. So that means if you look carefully now, everything is done, sir. That means not only we have connected the port number 2 with the D0 to D7, as well as we can use these ports, sir. We can use port number 0, we can use port number 3, we can use port number 1 for this purpose, but you are choosing port number 1 because you have seen the port number 3 is basically chosen for the timer operation. Here we are not interested. So now please choose this port number 1. Port number 1 will be chosen to supply these RS, RW and enable. Suppose I'm just clearing this doubt here only because if you want to do some more interfacing at that time, suppose instead of this RS, RW, EM, there are 5 signals which you need to control. So in that case, instead of using three bits of the port number 1, you can use those other bit also which you have grounded. Is this point clear or not? Yes or no? Please tell me yes or no.
Yes, sir.
Okay, so that means you can use any port. Sorry, this is 3 to 7. Now that means this is simplest diagram. So now I'm going to draw this diagram again for you all because now, sir, we are very much clear, sir. Now see, I'm just drawing. Okay, this is our microcontroller, sir, and this is our LCD. We know first of all we will draw. There is one pin RS pin. There is one pin that means read and write pin, sir, and there is another pin that is called enable pin, sir. Okay, sir. There was another pin that is VCC pin, and there was another pin that is the ground pin. The ground will be given to this. VCC will be given 5 volt. Okay. Now there is another pin from D0 to D7, sir. D0 to D7. There was another pin. So many pins. 1 to 7. So this pin might be, this pin will be connected to the port number 0. These pins are basically connected to the microcontroller with the port number. This is port number 2. Now this is connected to the port number 1 of some bit, port number 2 of some bit, port number 1 of some bit. We can choose anything. For example, you can choose port number 1 7 bit, port number 1 6 bit, port number 1 5 bit, so on. And then rest of this between port number 0 to port number 1 to 4 you can select by that you can select as a ground. It basically depend upon you which port bit you want to use. That's it. So this is you are selecting, and then this is the picture of your the connection. That means you are connecting this one with this one, this one, this one, and VCC, and this is. So this means this is basically 1. This is 2, 3, 4, and 5 and 6. This is the 6 pin, 7 pin we basically require to interface our microcontroller or our LCD. So this is our LCD, and if this picture is clear, now the programming will become very much easy. Because if you know this picture, if you keep these pictures are clear, everything or programming will become is very easy. The only thing is that I will tell you what to do. Okay, is it clear? Is this point is clear? Please, yes or no, at least.
Yes, sir.
Yes,
Okay,
sir. Yes, sir.
now coming to the very important discussion of this type, when you do initialize, when you do transfer now, what happen? You have to do use the initialization command. There are so many initialization command. This is called initialization. Initialization command. Initialization commands. These commands are 38H. The 38H command means you want to select. If you want to select the LCD, that means LCD is selected. If you want to select any LCD, then you have to first write in the command register what you want to write. You have to write 38H. Okay, sir. Now, if you want to write, if you want to select LCD, you have to do, if you have to send the command 30H. Now, if you want to display something, or if you want to display on the display, if you want to on the cursor, if you want to cursor blinking, for that you need a command 0FH. The meaning of this command is that the cursor on, the display on, or we can say that cursor blinking. That means this is the command for doing all these jobs. If you select LCD now, if you don't send this command, then your display will not on. Their cursor will not be there, and there will be no cursor blinking there. If you forget to move this command inside your LCD, so this command is used to do this job. Okay, sir, nice. There is another command 01H. This, what is the meaning of this class? The meaning of this class is that clear the display. That means if earlier suppose anything was written on this screen, or by default something was there, we don't want to see that. So in that case, if you want to clear the display, the clearing the display command is 01H. Okay, sir. Please remember this word. This later, please don't forget 30H. First of all, we will select, then we will cursor on the LCD, and then we will clear. This process will be followed. First select, then display, and then clear the display. Okay. And then what we will do? Then we will do one another command. This is called 6HH, 6CH. The meaning of this is that cursor increment. Cursor increment. That means once everything is written, the cursor will automatically, suppose the cursor will be blinking like this here. Now anything is written here, the cursor will start blinking here. So that means this command is that cursor increment from left to right. This is very important. So this is basically, if you want to write something, the cursor will be incremented from left to right. The command for this is 06. Okay. Now last command is 80H. The last command is that is now cursor home. This is called cursor home. That means line number one, and the position number 1. So last time what you want to do, that means if you want to do you want to move your cursor back to your home, that this command is 80H. So ideally speaking, this command we need to follow. And if you remember, if you look at this, first of all, what is that? 38 we will follow. 38 command select. After 38, 0F is on the display. 01 is basically clear the display. 06 is basically increment the cursor, and 80H is basically the moving the cursor back home. So these command we will not forget, and this command we will be using when doing the programming part. Is it clear to all of you?
Yes, sir.
Okay, so now we will be moving to the programming parts. Now, sir, only thing is that how to write a program for this. The last part is that how to write a program for this, sir. And the program part is very easy. I'm writing simple thing here. So this will be very much useful for you. So first of all, what you have used, sir, we have used port number 2. This is okay. We have used port number 1.0, and we have used port number 1.1, and we have used port number 1.2. And what we have collected with this port 0.10, we have connected, if I am not wrong, we have connected, just look at this previous picture, we will be seeing what we have connected. So we will be seeing what we have connected. We have connected, yeah, we have connected RS, RW, and EN. Okay. So we will remember that what we have connected we have connected RS with this, and we have connected read and write pin here, and we have connected the enable pin with this one, and we have connected the D0 to D0 D7 pin with this port. That's it. That means these, while writing a program, these things we must remember what port we are using for what purpose. This is very important to write a program. So before writing these, sir, we must be going to write a very important thing. Sir, what we are doing now, we are writing a very beautiful things. What beautiful things you are writing, sir? That means, sir, first of all, we write like this, sir. What we are doing, sir? We are writing O R G. If you remember, every time we are writing 0, 0, 0, 0 H. This we are writing. Sir, for example, we don't want to start our program from this position. We want to start our program from the point 0500H. So what we will do? Okay, we can do this, sir. So we can start your program from there also. So instead of this, you have to write org 500H. That is now your program is starting from the 0500H. Then, sir, for example, if you want to display something on the board, I have already told you in the previous examples of 8086, if you want to display some message on the screen, what need to do? We need to define byte. If you remember, db. So db and bracket, what you want to write? Suppose I want to write d double e p and then space and my name. This message I want to write on our LCD. So please remember that as soon as this org, what is the meaning of this org, sir? The org meaning is that this is an assembler directive. This is an assembler directive. This is as same as what we are doing in 8086 programming. We are writing something now. We are writing some statement. That statements are telling your micro that assembler that what need to do. As soon as you write this statement now, what happen now? The assembler will go to the memory part. Have a look. This is your memory part, sir. The assembler will basically go to the this part, and what it will do, it will start writing or locating the space for that. They will be locating an space. For example, suppose this is space is from 05001. So what will do? It will 0500. It will allocate some space and see how many characters are there. 1, 2, 3, 4, and space is there. So 5, 6, 7, 8, 9, 10, and 11. To total 11 character you want to display on the screen. So what it will do, as soon as you will write, it will start from this location. As soon as you will write this now, what happen? Assembler will allocate some space. That means 501, 0502, 0503, 0504, 0505, and so on. That means D will be here, E will be here, E will be here, and P will be here, space will be here. That means, and the C will be here, and these will be so on. It will start allocating a space for the data which you have written. That the meaning of these two lines is that you are telling your assembler that we want to print, we want to display this letter on the LCD. Please reserve some space for this character. So as soon as you will do this, it will do this, and as well as it will preserve some space for your message what you want to communicate. Is this clear? These two lines are clear. You can start from 0500 or you can start from 000 also. No problem, sir. In this case, what will happen? This will start from 000 and this will start from 001 and 002 and so on. That does not have any meaning. Is it clear?
Yes, sir.
Yes.
Yes, sir.
Yes,
Okay.
sir.
So now, so I'm just writing the program again. So first of all, what we will do, sir, I will write a program like this. I will start our program. That means org 00. Sorry, I will be starting our program from 0500H. No problem. So as soon as I will do this, and then I will write db, and then in bracket I want to write something very small, not very big. So I'm just writing. So suppose I am writing hi, space deep. Just I want to write this message on the screen. Okay, so this is the message I am talking about. So I just want to write in a small message, hi deep. And now with what happened, it will be proposed. As soon as I will do this, assembler will write this. So I'm just writing this. So 0500 will get H, 0501 will get I, and 0502 will get an space, 0503 will get an D, and 0504 will get E, and then 055 will get E, and then 0506 will get the P. So the total number of characters or total number of message, this is 7. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. This will be very important, because why I am counting this? How many characters? Total 7 characters are there. Okay. We will not miss space or anything. We will count those also, because for space also it required in space. So as soon as I will write this, so first of all I'm removing this. So now, okay, this is 7 character. We are interested in displaying some of the code. So what we will do? So first of all, what we will do? Now first use of this register, have a look. This is the program move the data pointer register. Remember, this is a data pointer register. Now you want to move that something. What data you want to move into the data pointer? From where you want to start your program? Sir, we want to start our program from 0500. This we don't want to start our program from 000. So we have to initialize our the data pointer register by the value 0500H. Is this clear to all of you? Suppose you are starting from some another location. At that time, you have to change this value. Yes or no? Yes or no? Please tell me.
Yes, sir. Yes, sir.
Good. So now the first of all,
Yes,
what
sir.
we will do, we will initialize our data pointer register, because we are saving or we have written down 0500. So it is our first duty to assign, or we will our data pointer register to the location 0500. So now our pointer will be locating at this point. So now after this, what we will do? Have a look what need to do. So first of all, the first instruction I am writing a very beautiful instruction. If you look at this instruction, you will realize what I am talking about. See, this is the initialization. Program is starting from here. Move. See what I am moving. Move in the accumulator the data 38H. Remember that 38H? The 38 is the command to initialize of initialization command to select your LCD. Is it clear to all of you? Now,
Yes, sir.
selecting the command initialization value. Now we have to execute. You have to execute a CA call. This is called absolute call. You are calling some program that is named as MCMD. CMD indicate command, because this 38 is not a data. This 38 is basically a command. What command it is giving? It is giving to select the LCD of your what you want to connect, and that is why you are calling a command that is CMD. CMD is a call. CMD is a command. Now I'm deleting this, because I want to write here only what is the subroutine program for command. So what is basically command is doing? This is very important, that just after writing a command initialization value 38, you are calling some function that is known as CMD. What is this subroutine program of CMD? Just show this. So CMD is C. Have a look. CMD, when you see, this is a command. So first of all, move P2 comma A. See, that means excellent. That means just after this instruction is basically executed when called. So whatever command you have put into the accumulator A, same command is now going on the port number 2. See, that means on the port number 2, you are sending those 38 data. The 38 is an 8-bit data. That 8-bit data will go to the port number 2. Is I am clear to all of you? As soon as you will write this and then you will execute this program, this will execute. The first line says that whatever you have put in the command accumulator, the same will be moved into the port number 2. Is it clear?
Yes, sir.
Yes, sir.
Now, okay, now we will be see. First of all, tell me whether it is a command or data. So this is a command. Which pin you want to that means RS will be 1 or 0. What register you will select? So we will select register command register. To select a command register, RS should be 0 or 1. RS should be 0 or 1. See, RS should be 0. That means RS should be 0 to select the command register. That means you have to clear CLR. That means clear the P1.0. Because you have to put your RS is equal to 0, because RS is equal to 0 means you want to send this data to command register, not the data register, because this is a command. So this data is a command. You want to send this command to your from the microcontroller to the LCD. So that means you are writing, you will first of all, what you will do, you will select your RS as 0. So selecting RS is equal to 0 means you have to clear that byte with which it is connected. The RS is connected with port number 1, bit number 0. Is it clear? Yes or no? Please tell me.
Yes, sir.
Now, whether you want to write something on the LCD or you are reading something on the LCD. So we want to write command on the LCD. So writing a command means we have to again we have to clear your this CLR, clear your port number 1, bit number 1, because you are connected. The read and write bar is basically connected with this one. Read and write bar is connected with this one. You want this basically 0. You want this 0 because you want to do writing. Writing means you need to select this is equal to 0. So that is why you are clearing that bit also. Here also you want to select RS is equal to 0 because this is means command register. This is basically a command register. Here this 38 data is basically command, not data. So now you want to send the command to the microcontroller from the microcontroller to LCD. So that is the way. Now, sir, last thing what you told. First of all, you have to enable your pin and then you have to disable your pin. So this is very simple, sir. First of all, we have to enable your pin. Set bit, which bit? Port number 1, bit number 2, and then you have to reset your pin. That means clear port number 1, bit number 2. Is this clear? So this is basically, and meaning of this is enable 1 and then disable that pin. The meaning of these two lines is that first of all you are enabling and then you are disabling. That's it. As soon as you will enable for some time now, whatever data is at O2, it will be transferred to your command register. This is as simple as it is written. That means as soon as you will set and then reset now, as soon as you will, it will be on now. What happened? Everything, whatever is at port 2 will be transferred to your command register, because here command register, here data is at P2. Here you are selecting command register and here you are selecting, you have to write, and then as soon as you will execute this instruction now, whatever data is at that P2 will be going inside your the LCD, and then your LCD is selected. That's it. Is it clear to all of you? Yes or no? Then we can write again one beautiful line that is called return. Now we want to return to the again our. So this meaning is that as soon as you will load some value into the accumulator, then you are calling a function that is command. This line will be executed. Executing this line means that means 38 command has been sent to your LCD. Now your LCD is selected. Done. Okay, sir. Once LCD is selected, this is the meaning of this is that LCD is selected. Now this LCD is selected. Now you have to again move a command to on the display, on the cursor. So that means you want to again send another command. That command is again move a comma has, what was the further that command? That command is 0F. That means you remember the cursor on or the display on command is 0FH. Simple, sir. Okay. That means 0F we want to send into the accumulator. And then again, we will call the same function A call CMD. Again, it will be executed. As soon as it will be executed, again, your display is on. Display on. Okay, now if the display is on, so if any rubbish or garbage value is there, we want to select or we want to clear. We want to clear our screen. Move accumulator. What command you want to send for clearing? So this command is 0 1h. 0 1h. Again, we have to again call the same function. Call the same command function because you are sending the command. As soon as it will be executed, what happened? It will basically clear the screen. The screen is clear. Okay, once the screen is clear, the last is that home screen. So that means this is move accumulator A has last one is ATH, and then we have to call a call and then CMD. The meaning of this is that home is the cursor is home. Again, the cursor will reach to the home. So these are the command. That is now you before sending some data to the LCD, you need to you need this command to be executed. First of all, you have to select your display LCD. Then you have to on your display. Then you have to clear the screen. Then you have to move the cursor to the home position. That's it. And if you remember this command subroutine program is very simple, sir. There is nothing. Only thing is that whatever data is coming inside A, you move this into the port 2. Now port 2 is having data 38, but this will not go to your microcontroller until and unless RS is selected, until and unless read and write is decided, and until and unless enable is 1 or 0. So now once this is there, so these 4 instructions need to be executed. This will basically sending whatever data is present on the P2. So if you want to write or write, this will tell you the read, write, and write. First of all, where you want to send at command register or the data. First of all, this is command, sir. So we want to send this data into command register. So for that, we have to clear this. That's it. Now reverse will be true for the data. So now the subroutine program for the data I'm writing here. So for data, now tell me what is this subroutine program, sir? The data very simple, sir. For data subroutine program will be different, but for data also we need to call something, sir. So now I'm just going to tell you how to write to call data and where to call data. So after doing all these things, sir, after doing all these things, sir, now we will move something inside this. This line is very important. Move. Move. Now we are using one register that is called R3 or R7 register. And then we are moving inside this. How many space we have allocated? If you remember, 7 space we have remembered. So for that, we have to load R7 at the count which we want to move. The count is 07H. So if the character will be large, so we have to load those value into the register. This R7 is the count register and the initial register is move R0, hash is basically 00H. So that means you want to move that is 00, 01, 02 and 03 and so on. You have to move to 07. So we have to load those value at this point. To total 7 characters. So we will type here 6 also because 7 characters 00 and 6 correct. So that means this basically this is the initialization and this is the final count. So we have to load the initial count in R1 and then we have to load the final count into the register R7. These two registers will decide how many byte or how many character you want to display on the screen. After writing these two lines, this two line is basically just for your what how many data you want to transfer or how many character you want to transfer. That's it. Suppose if you want to transfer 10 character, then you have to load it with this 0 A, and if you want to transfer 8 character, then you have to write 8. You have to transfer 7 character, you have to write 7. That's it. And then you have to initialize from 0 0. That's it. Suppose you are initializing here from 0 1, you can do this, but you have to increase this one because and then you have to move this from 0 1 to 0 8. But this is the best way to initialize from the 0 0 and then we have to move to the 0 7. That's it. Now after initialization, we are going to write a program. This is called the program. Now what is the bit program? Move A, comma, R not C. What you are moving? Sir, we are moving the R not value inside the A. Okay. Then after that, we have to move A, comma, at the rate A plus BPTR. This is basically very interesting. So now the meaning of it there, sir, we are basically at 05001 location. So we have to take this data and then we have to move to 501 and then 502 and 503 and so on. So how it will be increasing? This will be increased from this one. See what is the data? This is basically your 500. Now you are adding what? Zero. What is the value has zero? This is 00 and the same 00 you are moving into the A and then you are adding these two address. That means this is 00 plus this is 0500. So when you add this, the ultimate result will be 0500 and the content of that, see at the rate is there. So at the rate of this, the content of this will be, the content is H. This character will go to the A part and then what happens? We have to call the function. This is called a call and this is basically call is data. Here you can call the data now because this H is basically a data. I is your data, space is your data, D is your data, E is your data, E is your data, and P is your data. These are data. Now you are interested in data. You are calling the data subroutine program. So how, what is the subroutine program for data? This will be not difficult, sir, because we have prepared the command. This is the data subroutine program. In this also, we have to write the same simple line. We have to move something to the port number 2, comma A. That this time, whatever data is coming, we want to send this data to the port number 2. So this will go to the port number 2. Now we want to send this data to the this LCD. Then what you need to do before sending this, we have to select what we have to select. We have to select the bit that means which pin RS. Yes. So that means we have to select, that means set the bit, which bit, that means port number 1.0 we have to set and then again we have to clear. This we have to set. As soon as you will set, that means RS is equal to 1. That means it is means that data register has been set and then we have to clear what we need to clear, that is P 1.1 is basically need to clear. This is nothing but the right bar and read. So we are doing right. So this is clear. And then again, what we need to do again, same sir, set the bit that is P 1.2 we have to set. And again, we have to clear the P 1.2. This is basically your enable. Enable pin is 1 and then it will become 0. Simple. There is nothing different. Only different is that in the previous data subroutine program as well as command subroutine program, the only thing is that we have to select this address RS. One time we have to put RS is equal to 1. In this time we have to put RS is equal to 0. That's it. So that is the only difference between this subroutine program of data and command, because this will tell you whether you are sending the data or whether you are sending the command. So you are sending in, you are interested in data. So you have to select the RS pin. RS is equal to 1. If you are sending the command now. So again, it will call the program and then it will basically read. This is the simplest. So subroutine program for data is similar to the subroutine program of command. The only difference is that here you will select the RS is equal to 1. Selecting the RS is equal to 1 means you have to set the port number 1, bit number 0 is equal to 1 instead of clearing the port number 1 to 0. That is the only thing you can do. So now, sir, now what will happen? This will go and the data will be executed. That means now H is basically moved onto the LCD. Now what will happen, sir? So first of all, because we are interested now, we will be interested in 501, not 5001. Then we have to increment the R naught, because when R naught will be 00, incrementing R naught means it will increment the R00 to 001. So now it will become 001 after moving. Then we have to write, this is called the DJNG. This meaning of this instruction is that decrement, D for decrement and J and G, J and Z for jump on no zero. Which condition you will check? We will check the resistor value inside the R7. Then we will move to the again portion. This is an again. Where is again starting? Sir, again is starting at this point here. Here from here we will be starting this again. So the again program is start from here. So that means if the resistor value is not, what is the meaning of this? R7 is 07. The meaning this instruction is doing, first of all, it will decrement. Okay, then it will check whether it is 0 or not. If it is not 0, then again it will go to this location. When this will go to the again location, see now R0 will be 0, 1 because you have incremented. Now this 0, 1 will go to the A. Now this A is basically having 0, 1. When this will be added, this will become 0, 5, 0, 0, 1, and then it will again go to the execute this program, and this program will continue. Again it will go to the here. Now again it will decrement to 0, 5, and then it will check to 0, 0. If it is not 0, again this will go to this program, and this program will continue until and unless this R7 will become 0, 0. As soon as it will become 0, 0, 0, then the last line is that sort jump. We have already seen, to stop the microcontroller program, we have to write this line. This is called here sort jump here. So that means once it will be moved to this point, now this program will be here only. That means this program has been stopped. Is it clear to all of you? Is the plot, is the program is clear?
Yes, sir.
Okay,
Yeah, yes,
now
sir.
yeah. Now, before going to this detail, now I'm going writing separately for the sake of simplicity. So the every if anyone has doubt, so this will be clear to all of you. First of all, sir, this is the data subroutine program. I am writing the separately. This is the program subroutine program for the command. Okay, so just writing this. This is the subroutine program for command. I am writing separately CMD. This is the separate program for command, and this is the subroutine program for the data. I'm just going to show you the differences and the similarity. Sir, in the command or the data, everything is same. Everything is there same. That means whatever is coming, see, whatever is coming, move that content into the A. That's it. Sorry. Whatever is coming, you have to move that into P2. That's it. That means in subroutine program, whatever is coming, we have to move that A into the P2. Simple. Here also, whatever is this, whether it is a data or command, I will decide last. Whatever is coming, we have to move that thing into the P2. That's it, port number 2. Because port number 2, the data will be written from the port number 2 only. The command will be written from the port number 2 only. So whatever you are taking, the same will be basically given to the port number 2. Okay, now just after that, we have to decide whether you are sending command or whether you are sending data. So if you are sending command, this is an RS register. So RS is equal to 0 is basically a command, and RS is equal to 1 is basically for data. And this RS pin is basically connected to the port number 1 bit number 0. And this RS pin is basically connected to the port number 1 bit number 0. So we know this RS pin is connected with this pin number. So now we have to set or clear those pins. So first of all, if you want to reset this pin, what will happen? We have to write CLR, that means clear the port number 1 bit number 0. Now here we don't want to set, because here we want to set. So we have to write this, set the data, set the bit. Which bit you want to set? Port number 1, 0. This is the only thing. That means here you want to select RS is equal to 0. That we are, you are writing clear. Here you want to select the RS is equal to 1. That is why set bit is equal to port number 1.0. That's it. After selecting this, now it is decided that what you want to do, whether you are sending data. So this will store the data into the command register, and this will store the data into the data register. Now, after that, we have to write a very beautiful line. That line is basically write or read. If you, whether you want to do a write or read. So this is write and this is read bar. There are read and write bar. So this will be 0 for writing, and here also you are writing only. So this will be 0. If this is 0, then you have to write simply, you have to write this only. Clear port number 1.1, and here also clear port number one, bit number one. That's it. Now, after that simple line you have told, sir, we have to enable and then disable. So enable pin is collected. That is first of all, you have to set the bit port number one, bit number two, and then you have to clear. After submit, clear port number one, and here also you have to set the bit, that means port number one, two, and then we have to clear, that means port number one, two, zero. That's it. And then we have to write a very beautiful line. This is called return to the main program. And here this is also called the return to the main program. That means after executing this program, please return to the main program. After returning to the program, please return to the main program. Now, is it clear? Is there any doubt? Please tell me. Yes or no? Please tell me.
No doubt, sir.
Okay. Now
No,
one more thing is
no.
that. More thing is that. Sir, before writing this line, there one line is very beautifully written. The line was that A, comma, has either 30H or 01H or 80HS or 0FH. All these are basically nothing but the command initialization command. The meaning of this is select LCD. Meaning of this is that display the on the display. The meaning of this is clear the display. The meaning of it is this move back the cursor at the home position. That's it. That means we have 1, 2, 3, 4, 5. Total 5 instruction we have. One is 06. Okay, sorry. We forget one is 06. That means increment the cursor. So that means these are the 5 command you need to move inside your command register. Then only you can send the data. That's it. So that means you have to write these command or this instruction every now and then. So that means instead of writing 5 times this line, we are using a CMD call function. We will, after writing this line, we will call this. 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 That's it. Is it clear? Yes or no? Please.
Yes, sir.
Good. Now coming to the here, so here before that we have to write a beautiful line. That line is very, very important. The line is simple. Sir. The here we will write two important line, not only single. Here we are writing this line only now. No, here we will write two lines. What are those lines? Sir, remember that in the data section we have to write move anything, that means R not into the accumulator, and then this is very important, we have to write move C and the accumulator at the rate R naught plus data pointer register. So at the rate means whatever the content is present at this location, you want to move the content into the A, and then you have to move this content into the port. That's it. That means instead of writing a single move instruction, we will be very much careful. That means while calling the data function or data subroutine, this subroutine will be called after writing two lines. Those lines are move A, comma R naught, then move C, comma A at the rate R naught plus DPTR. Where DPTR has been set, it is not, it basically depends upon them. And now before this, sir, before this, there is very important two lines which is required. First of all, you have to initialize this R naught. You have to initialize this R naught with the 0, 0. That's it. Because if you are not initializing this R naught to 0, 0, suppose sir, your location was not starting from 500H. Okay, your starting address is 05001. So in this case, you can select your R naught as a 01 also, no problem, sir. In that case, I can select because our program is starting from 0500 and you have chosen the DPTR as 0500 only. So, but of course, if you have selected your DPTR only 0501H, then no need to select the R naught as a 01. This basically depend upon the programmer whether you want to select this 00 or whether you want to. This is basically from upon you. There is no rocket science in this. So it basically does not have any confusion. Please do not get confused. If anything, if any programmer or anyone has written something else, or you have not, this is not compulsory. You can initialize 00s. This is not compulsory rule. Yes, you can choose this accordingly, but this is the simplest way. Choose this as a program DPTR as a 0500, and then you will choose 00, and then see what will happen. After writing this program, sir, then we have to call this data function. After calling this function, please remember that two line. After executing this program, we must remember that we have to first increment. Just after calling, we have to increment R naught, and then we have to check the one condition. We have to decrement as well as we have to check this condition. Jump on no zero, that means R7. This is again we have to execute this program again and again until and unless this R7, whatever is stored value in the R7 will reaches to 0. And what value you choose in the R7, it basically depend upon you how many character you want to send. Suppose I want to send high, space and deep. So this, see how many characters are there: 1, 2, 3, 4, 5, 6, 7. So you have to choose 07H. Suppose I am just sending, I'm writing hello deep, HELLO base deep. So now see how many characters are here, sir. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have to load this R7 with 0AH because this is 10 character. So depending upon that, we have to load and then we have to initialize this R not register. Is it clear to all of you? Is there any difficulty? Hope you got this. Yes or no?
Yes, sir.
Now, if you are comfortable in interfacing the LCD, so if anyone asks you, please interface the LED. So LED is very simple, sir. In LED, what is there? Sir, LED is very simple. If you look at the LED, see, this is LED. So this is our LED we are talking about. So this is our LED. Okay. Now this is LED. In this, only one VCC will be there and one basically ground will be there. Okay. So this VCC is nothing but the supply. We can supply any port, one bit we can give to this voltage and then it will start working. So the interfacing LED is very simple. Only thing is that we have to supply, we have to give anything into this port. So now this can be done by using very simple programming, and I will tell you the programming and the methodology tomorrow for this LED interfacing. Then in the last, we will be dealing with the